the period for tangent is just a single pi. Now it's 2 pi. We're taking longer to complete a full rotation. All right, so up through the middle. And then in this case, remember, we can only graph that bottom half. We can only graph that top half. Okay? And notice if we were to highlight one complete cycle, if I'm going from negative pi to positive pi, that is a total distance of 2 pi. All right, remember your amplitude for tangent, there is not one because there's no max. Our domain in this case will be different because our first asymptote is in a new location. So all real numbers except the first one I see is at pi, and then we are going to add 2 pi k to the next one. All right, because notice again, if I go back, here's my first one. This is a full pi, and then this is another full pi. So between each asymptote, we have a total of 2 pi's. Okay? Your range is still negative infinity to infinity. No change there. Okay? All right, secant of 2 theta. All right, RB is 2. All right, the normal period for secant is 2 pi. I divide 2 pi by 2 to have pi. All right, which means we have condensed our graph because my new period is different than the original. All right, my new tick marks come from taking that new period, dividing by 4, since it's one of your 4 sine, cosine, cosecant, secant, my bad. All right, so my new tick marks are at pi over 4. All right, so again, come in and add marks at every pi over 4. All right, there is no coefficient out front, so really, again, secant has no amplitude, but there's no effect from a parent ghost graph either, okay? All right, so secant is the reciprocal of cosine. Cosine normally starts at 1, therefore secant will also have a point at 1. However, our very next line at pi over 4 will be undefined. And at pi over 2 will be down at negative 1. Another asymptote at pi, or sorry, this is really 3/4 pi, and then back at positive 1 at singular pi. All right, an asymptote at 1 1/4 down to negative, another asymptote at 1 3/4, and then back up to positive. All right, and we can continue that pattern. So notice how in this case, right, your pattern is still the same. All we've done is we've just condensed it. So instead of moving to the tick marks kind of that were already printed for you, you added new ones in, and you're just moving more frequently. Okay? All right, and then we sketch. So down, up, down, etc. Okay, all right, our domain will definitely change because we have asymptotes at a more frequent rate, so all real numbers except the first asymptote I see is at pi over 4, all right, plus minus. Now the distance between my asymptotes here is only a half pi, because this is a 1/4 and this is a 1/4, so together that makes 1/2 pi. So plus pi over 2k. All right, range-wise, we're still running from negative infinity to negative 1, pick back up at positive 1, and run to positive infinity. All right, for negative 2, cosine 2 theta. Now, even though it's written in front, this -2 is just a -2 constant. That's a vertical shift. Okay, it's just not written at the back, but it's not being multiplied, so that's a vertical shift down 2. And then this negative would represent a reflection over that new line of oscillation. Okay, so first, if we'd like, we could go ahead and just graph where our vertical shift is. We are down at -2 now. All right, our B in this case is 2. Cosine normally has a period of 2 pi. Divided by B gives me a new period of pi. So we've condensed it again. New tick marks, take my new period, divide that by 4. So I'm going to have new tick marks at every pi over 4. Now, if it helps you, since we have vertically shifted down, to just come down here and make your new tick marks on your new sort of x-axis, if you will, then sure, by all means, do that. Okay. All right. Cosine normally starts at 1. However, we have reflected, so cosine should start down 1 from the line of oscillation, which in our case is really down here at -3. Then we come back to the line, up 1, back to the line, down 1, to the line, up, to the line, down. All right, and repeat that pattern on the other side. My line is not very straight, that's okay. All right, and sketch. So again, we have condensed, so we are fitting a lot more waves in that space. It's only taking me 1 pi to get from the start of a cycle to the new. All right, our amplitude is still 1, so from the line of oscillation up to sort of my highest mountain, that's still only a distance of 1. Domain is no different, -infinity to infinity. My range, however, has changed. My lowest point is -3, and my highest point is -1. All right, one more like this before we throw it all together. All right, so negative cotangent of 0.25 theta. All right, my B value is 0.25. Cotangent normally has a period of pi, and if I divide pi by 0.25, that's really the same as multiplying by 4. So my new period is going to be 4 pi. So we have very much stretched it. All right, my new tick marks come from taking the new period and dividing by 2, because this is cotangent. 4 pi divided by 2 is 2 pi. So I will obviously use 0, but my next tick mark is not until 2 pi, and then in the opposite direction at -2 pi. The other 3 are not there. Okay? All right, so this is cotangent, and it's also a reflection. So at 0, cotangent is normally undefined. So I will have an asymptote here, which means we will have points at 0 for 2 pi and -2 pi. The question is just how it opens, okay? Cotangent normally opens down from left to right. But if I have reflected that, now I need to be opening up from left to right, okay? So just kind of envision if this graph were to extend, cotangent would do this sort of thing, okay? We obviously don't have that much space, so all we get to graph is it's rising to 0. Versus on the left-hand side, imagine that it came from the left, and then once we hit 0, we can only see the rising above section. All right, so amplitude, we obviously do not have one. All right, my range still going to be -infinity to infinity. All right, domain-wise, all real numbers except. Our very first asymptote is at 0, plus minus, and then it will end up being a whole 4 pi k before we see another asymptote, because notice that in this stretch of 2 pi, we can only see half of the cotangent wave. Plus this stretch of 2 pi, we see the other half of the cotangent wave. So 2 plus 2 is 4. It would be a whole 4 pi before we see another asymptote. Okay? All right, so now let's practice one where we put it all together. So -3 sine of theta plus pi plus 1. All right, the plus 1 is a vertical shift. So if we'd like, let's go ahead and add. That is where my new x-axis should be. Pen's dying. All right, the -3 means that we are going to have a reflection. The 3 itself means that we're going to have an amplitude change. So we are both changing our max and min while also reflecting. So we could even just come down here and add my new amplitude's 3. All right, our b value in front of theta is a 1, which is great because that does nothing to my period and nothing to my new tick marks. But if we go through that same process as before, sine normally has 2 pi divided by 1, that's still 2 pi. That's no different than normal. Then we would take my new period, divide by 4, so we're still going to have tick marks at every pi over 2. Again, that's just like before. All right, but notice in this case we do have a phase shift because we have a group. We have theta plus something in parentheses. All right, so out here to the side, if we were to set theta plus pi equal to 0 and solve, we would have a phase shift of -pi. Now notice there's not a blank for you to write that, but it is very important that you recognize that your graph has been shifted, okay? Specifically to the left by 1 pi. So over here at -pi, I'm going to add, kind of like we did yesterday, think of that as your new 0, 0. Okay? All right, so at this location, if that is kind of my 0, if you will, sine would normally start at 0. It will still start at 0. Let me pick a different color. All right. From there, sine would normally move up 1 and then back to the line. But if I have a -3, I now have to move down and 3 away from the line. So 1, 2, 3. All right. Back up to the line and then up 1, 2, 3 from the line. I know we ran out of space up there. That's okay. Back to the line, down 1, 2, 3 from the line, and then back up to the line. All right, and continue that pattern over here. Okay. All right, sketch. All right, our domain, still no different, -infinity to +infinity. Our range has gotten much larger. We're stretching all the way down from -2 up to +4, both included. Okay. All right, so I'll run through a few of these with you, and then I might leave a few to see kind of if you could do on your own and just show you what the final answers would be. All right, so we're not graphing these, but it just says complete the chart for all of the trig functions. Okay, so you will have a section on your quiz tomorrow that looks very similar to this table. All right, so if we look at number 1. All right, first question is, do we have an amplitude? Sine has an amplitude, obviously. And that new amplitude comes from multiplying by 4 in the front. All right. Reflection, yes or no? In this case, no, because that 4 is not a -4. All right. For period, we need to look at B and see if it's changed. All right. In front of theta, my B value is 1. That is no different than before, so my period should still be 2 pi. All right. My period is 2 pi. I would divide that by 4 to get the new tick marks.